Welcome back to the deep dive. Today we're doing something a little different.
Yeah, this one is pretty unique.
We have a stack of source material here, excerpts from the Microsoft AI Diffusion report, but the thing is, it's almost entirely visual.
Exactly. We're not reading pages of text. Our whole mission here is to interpret the raw charts, the diagrams, these really fascinating abstract visuals.
So we're translating the pictures, basically.
We are. We're turning data visualization into the actual story. Because when a report like this comes out, the visuals are often the fastest way to get to the core findings.
If you know how to read them.
If you know how to read the colors and the geometry, yes. And the theme is AI diffusion, how it spreads.
And the very first thing that jumps out, I mean, you can't miss it, is this incredibly complex map of spoken languages.
That's just our starting point.
It immediately tells you the scope here is, well, it's global. This isn't just a look at a few Western countries.
No, this is a massive undertaking, but the way it visualizes that global spread is what's really key.
It looks like a mosaic or something. All these little connected shapes.
That's right. It uses what are called tessellated shapes, hexagons in this case. And the size of each shape tells you its relative weight, its volume within this AI data set.
Okay, let's unpack that one, because one language, one shape just absolutely dominates the entire image.
It really does.
It's English. It's this massive dark blue shape right in the center, and it feels like it takes up almost half the space.
It's the anchor, and that's not just showing, high adoption. It's establishing the current gravitational center for AI.
The center of gravity.
For the data, for development, for interaction. It's telling us that even as the tech is used globally, the ecosystem that feeds it is still overwhelmingly English-centric.
I see that. I see the dominance, but here's where I want to push back a bit. If they're tracking dozens of other languages, and the map is so colorful and varied, doesn't that point to a more decentralized, fragmented effort?
That's a great point, and it's a fair question. The short answer is really about scale. Yes, the report confirms this huge global reach. You can see it clearly. Surrounding that English core, you've got this crucial second tier of languages.
The next biggest shapes.
Exactly. Russian, French, German, Chinese, Japanese, Portuguese, Italian. These are the teal and dark green clusters. They show huge established adoption outside the Anglosphere.
And then beyond those, it just kind of explodes into all these tiny little shapes.
It really does. I mean, look at the sheer breadth of the smaller light green and gray shapes. We're seeing languages like Arabic, Korean, Polish, Turkish, Indonesian.
I see Thai, Croatian, Finnish in there too.
Right. The fact that they are even analyzing data volume for such a diverse, fragmented group shows just how ambitious this research is.
But let's go back to that idea of scale, the
Yeah.
disparity, the gap between that huge English shape and, say, the little cluster for Polish or Arabic. What does that hierarchy actually imply for AI diffusion?
It implies a massive infrastructural challenge.
How so?
Well, if the models are mostly trained on English data and they interact most fluently in English, then true diffusion, equitable adoption and benefit is naturally going to cluster.
It'll stick to the places and people who are comfortable in that English framework.
Exactly. So the fragmentation you pointed out, it confirms global interest for sure.
Yeah.
But it also confirms just how uneven the adoption landscape is right now. This isn't just about language, it's about data parity.
So the visual story is global reach, but with localized success and a fundamental English bias. That makes a lot of sense.
It does.
Okay, let's shift gears. Let's move from language and geography to the pure data visualizations, the math.
Right. We're moving to the scatter plots now, and there are several of them. You'll see these charts filled with thousands of dots, all different sizes and colors.
Yeah, I'm seeing blue, red, yellow, green, pink, even some mauve or brown shades.
The colors are just categorizing different segments or variables. But the real story, the important part, is in the clustering, the way they group together.
This is where I thought it got really interesting. The dots aren't just spread out evenly. There are these dense clouds of them, huge concentrations, especially in the top right corner of the charts. What does that tell us?
That concentration is basically a data analyst's shorthand for success.
Okay.
When you see a heavy cluster in that top right quadrant, it almost always points to a strong correlation between whatever is being measured on the X and Y axis.
So give us an idea of what those axes might represent in a report about AI diffusion.
Typically, you'd be tracking something like investment versus outcome. For example, the x-axis could be something like venture capital investment, and the y-axis could be rate of AI adoption.
Ah, I see.
And that clustering tells you that diffusion isn't happening uniformly, it's happening intensely and it's self-reinforcing in very specific segments, those colored dots that already have a high level of resources or maturity.
So those big red and blue clouds in the top right are the markets where the tech is really taking off.
Yeah.
High investment is leading directly to high adoption.
Exactly right. And the dots scattered down at the bottom left are maybe the segments that are lagging behind.
And the different colors, the yellow versus the pink clusters.
That tells us those successful segments are fundamentally different from one another. Maybe they're different industries or product categories, or maybe they even map back to those linguistic groups we just talked about.
So success is happening in these very targeted, optimized silos.
Precisely.
Okay, so moving on from the pure math, we also get these fragments that look like actual maps, bits of geography colored in bright red, yellow, and blue.
Yeah, they're set against these striped gray and white backgrounds. They definitely look like pieces of a much larger global picture.
And when you see them alongside those scatter plots, it really feels like they're trying to layer the analysis.
That's a good way to put it. The geographic visual lets us place those successful clusters onto an actual map. And the colors, red, yellow, blue, are very conventional in these kinds of reports.
So if we're going by standard conventions, how would we interpret those colors for AI adoption?
Well, red usually signifies high momentum, rapid growth. These are the early adopter regions where diffusion is accelerating fast.
Okay, red is hot. What about yellow?
Yellow often represents emerging or transitional markets, so areas that are growing, but they haven't quite hit that steep acceleration phase yet.
Got it. And blue?
Blue is typically for established or even saturated markets, places where the core AI tech is already widely deployed and the adoption curve is starting to flatten out.
And that striped background you mentioned, it seems important. It makes it feel like these aren't just countries, but maybe specific zones that the report's authors have defined.
I think that's exactly right. It reinforces this whole idea of segmentation. They're deliberately carving up the world to see how AI flows across different environments, maybe regulatory or market environments.
Trying to figure out why a red region is succeeding faster than a yellow one right next to it.
Exactly. They're pinpointing the conditions for success.
Now we get to the really abstract stuff, the structural models. These were the hardest for me to get a handle on.
They're definitely the most conceptual.
We see one image of these blue swirling ribbon-like forms, and then there's that complex sphere made of all those hexagonal cells, teal, blue, and light green. It looks almost like a molecule.
These visuals move the analysis away from the who, the languages, and the where, the geography, and more toward the how. How the underlying infrastructure or the model itself actually operates. The fact that a diffusion report includes these tells you they're analyzing the very architecture that lets this technology spread.
So if we take that sphere, that network model with all the different colored cells, what is it trying to show us?
It's visualizing complexity and connectivity. The different colors likely represent the different segments we've already been talking about.
Ah, so the linguistic groups or those successful clusters from the scatter plots.
Could be. And the structure of the sphere shows how they're all interconnected. If the dark blue shapes are all clustered in the middle and the light green ones are on the edges, it's a visual confirmation of that centralized network we talked about earlier.
So even at this completely abstract structural level, the finding is the same as the language map. It's all about centralization.
It echoes it perfectly.
And the swirling blue ribbons could be the flow of data, funneling through those core nodes, connecting the successful clusters, but leaving the others more on the periphery.
That's the key synthesis right there. This analysis is suggesting that the efficiency of AI diffusion depends on this centralized network structure. If it were truly decentralized and uniform, you'd expect a much more scattered, less organized visual.
But this sphere is highly organized.
It shows an infrastructure that's been designed for scalable, segmented growth. It's not accidental.
So this whole deep dive really shows that this Microsoft report isn't just measuring who's using AI, it's mapping a whole technological ecosystem.
An ecosystem defined by, yes, hierarchy and segmentation.
When you connect all the dots, it's a pretty clear picture.
It is. You start with the global footprint from the language map, which confirms massive international interest. But then you see that all that interest is being funneled through an overwhelmingly English-centric foundation.
And that linguistic hierarchy maps directly to the clusters we saw in the data plots.
Right. Diffusion succeeds intensely in these very specific resource-rich and maybe linguistically favored segments.
And the geographic and structural visuals just give us the why, the framework for that segmentation, whether it's market maturity or network design.
It's a roadmap of technological spread. It shows that diffusion isn't a tide that raises all boats equally. It's more like a targeted stream that floods specific prepared valleys.
And leaves a lot of the surrounding landscape pretty dry.
Exactly.
So wrapping this all up, what are the core takeaways from reading the visual story of this report?
I'd say there are two main ones.
Oh.
First, the immense linguistic breadth shows AI is a truly global consideration. It spans dozens of languages, which is significant. But, and this is the second point, that global reach is structurally unbalanced. The center of gravity is firmly planted in English data and interaction, and all the other visuals confirm that adoption is complex, it's highly segmented, and it thrives in these distinct clusters.
So success isn't accidental. It's concentrated, either by design or by resource advantage.
That's the story the visuals tell.
Which brings us to a final, crucial question for you, the listener, to think about as you watch all of this unfold.
Given all this evidence, this overwhelming evidence of a highly segmented, centralized technological spread, what would actually need to change?
What specific infrastructure or policy changes would it take to break down that massive linguistic and resource hierarchy we've just analyzed?
And how do we enable truly uniform, equitable AI diffusion across all those smaller language segments we saw on the map?
It's a huge question, and it's something worth exploring as AI continues to scale globally.